Hello everyone and welcome back to 120. I'm not going to use my cam today because I'm basically bald right now. I had to shave my head off for a medical reason. So I'll keep that hidden so you don't have to suffer that. But today we're continuing and we're actually finishing up now the last section, which is on arrays. We're getting into our very last... why is this on? I guess just because Zoom has control of it. We're getting into our very last section here, which means as of this lecture, as of this instant right now, you are now welcome to use every concept available in the C++ programming language, except for classes. If you're using classes and things, I'd be a little suspicious still. I mean, you can. If you know classes well enough, go for it. You can use any tools available to you, just as long as it's clear that you understand the concept. It's fine with me. So arrays, like I said, are the last subject. I'm going to cover them today. Plan for today, we're going to go through the first, no erasers. I'm going to try to get through here because this is the sections you need for this week's lab. But first I do want to mention a couple of things. So let me switch back over to this. So first of all, for anyone that requested an extension to lab 11, you got it. I gave an extension to everyone. In that lab 11, if I go through to, let me make sure this doesn't show any grades, hang on. Yeah, this isn't showing anything. Okay, so lab 11 on the pet tags thing that was due last week. I gave an extension to everyone. Notice that now it is due on the 21st. Make sure I'm showing the right screen. Yeah, it is now due on the 21st. So you got an extra week for it for anyone that needed it. Along with that, I'm not going to go through the solutions this week, however, because of that extension. So I'm going to actually cancel the Zoom meetings for this week in place of just being available. So normally I do the Zoom meeting, go through solutions and stuff, but for this week, I just want you to get right to work on the next things. We got a lot to do, and you got to finish pet tags. Also notice that the other two, we have two parts for this week. You have arrays and the fruit comparison, so you're actually going to revisit your midterm this week, which I'm going to talk about in a little bit today. But yeah, so this week I'm not going to lecture on anything for Wednesday, Friday, so I'm just going to let you get to work. I will be available, as always. I will be available from 1 to 3:45 on Monday and Wednesday. I don't have anything to really lecture about. I'm going to cover these two labs today as far as like how to do arrays and stuff. So yeah, so you don't have to attend necessarily. You should still spend that time to get the lab done. Ask your instructional assistants if you need help. But yeah, I just wanted to announce that again. This week's two lectures for Wednesday and Friday are canceled, and I'm going to cancel them right now so everyone can see it on the screen who doesn't listen to me talk. So again, that's the 17th, right? Let me just double check. 17th and 19th. And again, all I'm doing is canceling these two. I will still be available in Discord. As always, as every week, I'm always available, which means we just got 3 lectures left. So next week is the holiday, so we're off for the entire week next week. So we got this lecture today. We're not going to meet Wednesday, Friday. Then we're off for a whole week, and we'll come back on the 29th to cover the rest of structures and vectors and things, and then we'll have one final activity meeting for each of these. And then the very last week is just projects, getting your projects in and submitted. And I'll do a general question answer session on that week, but then you're getting ready for your final exam. So yeah, just know that we're almost done. Don't miss this 29th because I will also talk about the final exam on the 29th as well. So that's what's coming up. We're almost done. Just a couple weeks left of the class. Yeah. So there's that. And like I said, for these two as well, lab part 1 and part 2, you're going to see in the actual instructions or in the note I put in Discord in case you missed that. And there's still people who aren't in Discord, so I'll just bring it on the screen. So there's a little message here. So I extended lab 11 to be due this Friday. Lab part 1 is also due on the 21st this Sunday. In part 2, you can take until after the break, so it's due on the 28th. And what I mean by that is it says due on the 21st, but it is allowed. Yeah, it is allowed to be submitted before the 28th without any penalty. So I'm still putting it on the 21st so that you guys are more pressured to kind of get it done and actually enjoy your breaks. But if you need the extra week to do part 2, go for it. You can turn it in up to the 28th, which is the Sunday after our holiday. And yeah, then we'll come back on the 29th. I think there's one last lab 13, on arrays and vectors, and then you got projects and stuff to turn in for the last week before finals. So I'll say I might, if people request it, which is kind of unlikely, I might add a Zoom meeting for that final Monday to do a review of some sort, but I'd rather just let you work on review. Maybe I'll just post something because I want to make sure you have plenty of class time to get your projects and things in. So yeah, so I think that's everything I need to talk about. Again, that's due. I'll finish grading up your other stuff later. But again, anyone who sent me a message asking for Lab 11, I didn't respond because there were a lot of you. I think there was like 20 people asking for extensions, which is understandable. It's a big project. This is like, I would put this on the level of an actual implementable piece of code, like something you could actually market out there in a sense. Or you could just look for RFPs. Like people would pay you to write something at this level, I would say. So yeah, I think that's everything. I think that's all the announcements I need to make. Unless I forgot anything. Hopefully everyone turned in their part 3s. We got 56, so not everyone turned in. But your part 3 is due, or was due. If you needed an extra like couple of days, let me know. I can extend that for you as well. But you should be working on your projects now as well. And don't forget, for your project submissions, you're going to submit your code. Which, again, oh yeah, that's what I should point out. Let's go back over here. Oh yeah, I should talk about the X credit too. So you can see there's instructions here for project part 4. This is the last part of it. Now that part 3 is done, so read through that. And basically it tells you how to submit the code, tells you exactly what I'm looking for on the code walkthrough. So walk through this page here. 2 submissions. And again, make sure you don't give me any more than a 4-minute video. Remember, I have to watch everyone's, and I have 70 students, so if it's any longer than 4 minutes, I just do not physically have the time. And yeah, so make sure you stay in that timer. Again, the submissions are right here. For C, you're going to submit straight to Canvas here, but the other 2 are Gradescope submissions. Again, there's no auto-grader for your project because everyone's projects are totally different. And the test cases. So don't forget, for this test case 1, what you're going to submit is the test case thing that you submitted for part 3, and then fill in the rest of the table parts. So yeah, make sure you look over your grade for that. Okay, so make sure you read those. Again, the project just kind of works alongside our class. Ask a question regarding projects. If after class you check that, yes, I will check that after class. I had like I said, I have like 20 emails from people asking for Lab 11. So if you ask for something other than Lab 11, sorry, I just read the word extension probably and didn't look at it. But yeah, I'll look at yours after class. Just remind me if I forget. Yeah, of course. And then yeah, last thing, X credit opportunity. So for this week, we're going into chapter 8, as you notice. We're going to talk about arrays today. I'm just going to introduce the concept, show you some examples of them, give you a hint on how to use it for your lab. But that's it. That's what we're talking about this week. So we jumped past chapter 7. And if you look at chapter 7, it talks about classes, object functions, member functions, constructors, destructors, private member functions, structures, which we might talk structures a little bit. And basically it talks about something called object-oriented programming, which is a newer in quotes paradigm for computer science, but it's all about object-oriented programming. And that is what, I'm pretty sure that is what the title of course 121 is. It's all about that concept. So I'm going to give you a little incentive to read through this chapter here and get a little head start for your next semester, because this will help you if you do this assignment. This will help you do a little bit better in 121 for sure. Where all I want you to do is just read and work through chapter 7. You should be able to get the textbook for free from that Vital source link, maybe. If you can't, if you see right down here, I can't like publicly say this, but there's a link here that says this. This is the thing that you would need to do this assignment. So just click that link and you have it right there. And all I want you to do is just write me like 2 to 6 sentences on each of these sections telling me what they're about. So essentially just kind of read through it, summarize it, and then I'll give you up to 3% of your final grade. So for example, if you ended with an 88 after the final, completing this could get you to 91%. So I use it for borderlines, essentially. If you don't do this, though, I will not round your grade. So if you end up in 89.9 and you don't do this X credit assignment, then you're getting an 89.9. So remember that. And yeah, this should be available to you now, so you can see it. Again, this link right here, it's due on the 12th, which is the Sunday before finals week, I believe. Make sure, 12th. Yeah, it's due Sunday at midnight before finals week. And then again, we'll do our final for that whole week. Okay. I think that's it. I think that's all the stuff to talk about. Did anyone have any questions on anything I discussed before we talk about arrays? Oh, one more thing before. I mean, you can keep typing your questions if you're going to ask questions. But also note that there's a discussion that's going to show up here. It's going to show up in the next unit after the break. But do not do this discussion until after you finish your project, because this is a retrospective, which is a type of meeting that you do in Agile and other development methods where you essentially get together afterwards and you say, okay, what went wrong? What went right? What did we like about this? And so on. So this is your chance to share things that you learn from this project or in your development that can help others and others learn. Because then that's kind of what these courses all are about, is learning from other people, learning from my mistakes, learning from each other's mistakes, or learning from things that you've learned. Like if you found out something super cool in your project, like how to take keyboard right and left inputs, like someone asked about that the other day, put it in this discussion so that other people can learn from that and see that's possible. But again, don't do that until you're done with your project. So don't try to answer this discussion before you've done your final submission. That's the only warning I have. All right. Well, yeah, again, next week, fall recess. No Zooms. Okay, I think that's everything now. So any questions from anyone before we talk about arrays now? All right, arrays, which I'll let you keep thinking for 1 second because I want to get out a file so that I can demonstrate some stuff. File open. Was that files one? Lab 9 part 2? Part 2. Not this one. I know you can't see it. I'm bringing up something. I want to make sure I don't show the solution to this week's lab. Lab 9 part 2. Okay. All right, so let's talk about arrays. Again, at this point, you have now unlocked the entirety of the C++ language. I will allow you to use anything. So even if you really find a reason to use classes and so on, go for it. And you're going to learn about classes and public and more advanced design and pieces and object-oriented programming in 121 next semester. But you can still use that if you're comfortable with it at this point. I don't really mind. You can use anything at this point. Like this whole time, I've been saying don't use anything past what we covered, so I knew you covered the concepts. Well, now we've reached the end. We've covered the last concepts. So you're free to use any tools that we've discussed, including anything in this section. And we're not going to talk about vectors until after the break, but if you find that you really want to use a vector instead of an array like we talked about, go for it. So anyway, arrays. I've been throwing this word around. What are arrays? Essentially, if you've ever had a case where you wanted to store a value of something and you wanted to store multiple values to the same thing, that would have been a use for an array. So for example, when we did this program right here, this file program, which I still haven't graded, I'll try to grade that today now that I remember I haven't graded it yet. You might have had this kind of experience here where I said, okay, April is the first month, and then May is the second month, and June is the third month. And this seems kind of clunky and awkward when we did it before, where I was saying assign these things different objects. Well, an array is a data type that allows you to store multiple individual things in one object. So for example, I could have called an object string months, and I can have a months being a data type that is essentially a one-dimensional array, where I can say this thing will have 5 entities in it, and then it could have April, May, or make them strings, April, May, June, July, August. So now I have this string here that has all of the different months in it stored as strings in the specific string entity, and I can access each one of those entities by something called an index, where essentially I have a variable now called months, where this is a array. In this array, if I think about it in sense of data, array itself, I'm not using my keyboard, so pardon my typing. An array called month with a 5 after it means that I've defined a variable month where normally I'd have month and I'd store it in one single cell, where this single cell now contains month of 0. It contains the first array in this list, which in my example here that I've given means it has April in that. And I can store a string in there. So I've stored a string in this, and I can use any data type for these different things. And since I said in this intro, I defined it as having 5 elements. That's what this thing is. This is the size of the array. That means I've set aside 5 blocks. 2, 3, I'm not going to write the things over and over again, but 4, and 5. And I can reference any one of these using this index, where the first one is labeled 0, the second one is 1, 2, 3, and 4 for the fifth one. Which this is a thing that is highly debated in computer science in general. Start counting at 0 or start counting at 1, which changes it differently for each one. Wouldn't index 0 be April? Yes. That's why I have it, right? Month 0? Unless you're talking about my code. So again, to address that question, this 5 up here defines how many elements I have. So by setting 5, I've made 5 boxes. And then I reference each box using the index in front. So month 0 references the first box of 5. Month 2 would be the third one. No worries. Okay, so anyway, back to what I was saying. Oh yeah, start at 0 or start at 1. So C++ starts counting at 0, which leads to something called an off by 1 error that I'm going to put on a slide in a little bit later. That happens quite often in programming. I actually have an off by 1 error on my laptop because whoever programmed the brightness function is off by 1, where my lowest brightness is actually my brightest brightness, because if I go all the way down to the bottom, it's off by 1 to the top. But other languages don't start at 0. Like other languages will start at 1 for their indexing instead. So just be aware that the first index is the 0th slot when we do our counting. So anyway, in my code, that means I don't even need this anymore. I don't even need to say the number of months or otherwise, because I know April is in the first slot. So if I wanted to get April out, I have months of 0. And I can find which slot April's in by iterating over this thing. So whatever I put in this reference thing right here, when I'm getting out a specific variable from an array object, this can be a number to reference any of these things. For example, months of 0 is April. And I should be able to extend this out. I guess I can't. Or months of 1 is May, months of 2 is June, and so on. But I can also use a variable to get this thing. So for example, I could say int I equals 0, and then I could use months of I to get the 0th slot, to get April out. So an example use for this is I could use a loop tool, for example, a for loop, and I could search through this array to find April. So this is kind of a hint for this week. This is why I'm spending so much time showing you this demo, and then we'll go through the specifics. But again, I could do int for I equals 0. As long as I is less than the number of max months, which is 5, 0, 1, 2, 3, 4, I plus plus, oops. And then what I'm going to do is by doing this, I can put months of I, and this loop now effectively looks at every single element of this array. So if I wanted to get the location of June, for example, I could put a conditional check and say if months of I is June. And then I can do something else with this. So if months of I equals June, that means whatever's in this ith slot is the word June. And then I could just say end loop, continue whatever I want. Because once I get here, once I get to I equals June, so I'd probably just do continue. Just break out of this loop set. Or just break. So once I get here, once I find June, then I will be set to the index location of June. So this is essentially a very, very short keyword search where I start with 0 and I look at months of 0. And essentially what that does is it goes into the array and grabs this first value. So 1i is equal to 0, it puts, is April equal to June? It says no, so then I go on to the next loop. I iterate 1 up. So now it's at months I equals 1, which takes May, puts it here, says, okay, is the second slot of my months array equal to June? Still not. Then it iterates one more time, goes to 2. Now I have the third slot with iterate 2. Is June equal to June? It says yes. At that point, I is equal to 2, since that's the one that got me. So if I break, now I have I equals 2, which I could just say, all right, the number of months total then, since I found the second slot, is equal to I. Or I could even do that in this specific loop. Go into this one right here. The number of months equals I before I break out. So that's just a small example of keyword search where I'm searching every single element of the array. And there's many other tools for this. The other thing, I can pass these through functions. So remember last week when we had that specific function where I had to kind of use that little trick on how to return 2 variables for the triangle, the right triangle, we had the base and the height. We can just return an array. We don't have to return 2 specific values. We can just return an array that holds 2 specific values and then use them once they're passed back, which I'll show you that as well in a little demo. But now that I've talked about it, shown you the demonstration, let's talk about the specifics of these, including the terminology and how to define them. And then you can ask me questions as we go, as I go back to that example a couple times. So, arrays. Array is a variable that can store multiple values of the same type. So this is important for right now, where right now we're kind of limited. So at my example right here, when I declared this array, I declared it as a string. And these are the month names. So maybe I'd want to change this to string months names. Get rid of this. Because these are held as strings. I could also have, you know, month numbers, like int month numbers. And there's 12 months total, so I put 12 as my slots. And then maybe that's just like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's numbers of each month. Now I'm also going to up this a little bit. Let's go to month names 12 and let's put in some more things. Specifically, I just want to put in January, March. Wait, there's one more. Everybody forgets February. All right, and then there's more, but I'm going to make a point with that in just a little bit, where essentially I've defined this as 12 things, and I'm initializing it with these values. Now, here's the other thing right now, is once I find this value, if I'm doing this hunt, then I have this array index I. So, if I were to use that I, and I were to use it in the month numbers array of I, then at this point, once I found that month numbers of I, once I found that that's equal to June, I've located the array index where June is. So in this case, let's put something that's on the screen. Let's say I'm looking for March. I'm looking for March, my thing. I go through my list. I go 0, which is January, false, February. March is the third one, which means I will be equal to 2. This will evaluate to true. And then if I use that 2 value in my month numbers, then I have whatever's in that slot. And this is what's known as a linked array. And I've used a lot of examples this semester where I've said, well, basically there's a much easier way to do this, but we can't do it yet, so don't worry about it. This is essentially that way, by associating the first slot of the month names array with the first slot of the month numbers array. So January is associated with 1, February is associated with 2, March is associated with 3, and so on. Which here isn't super useful because I just have the array, but what if I had a list of doubles that was the amount of rainfall for each of those months. And that also had 12. And then maybe I had some data, like in this one. Let's see, 3.03, 3.41, 3.03, 3.41, 2.65, 1.15, 2.65, and so on. I'm not going to put in the rest of them. But essentially now, if I found March, then I know my index for March is 2. And then I can use that index for the number of the month if I need it. But I can also use it for the rainfall for the amount of March, which is 2.65. Because notice that if I put rainfall amount of 2, that would be the rainfall amount in March. And then I could use that with an accumulator just like you did before. And this is like my big hint for the lab, where I could say something like total rainfall plus equals rainfall amount of March. And I could iterate that over every time and so on. So you're going to use most of this in this week's lab. Again, I'll give you a more specific example as we go. Let's go back to here. Let's go back through the specific definitions. Again, trying to really show you it in context so you can see the use of these. Because we're going to spend 2 weeks on arrays. Or effectively 3 weeks since we're off next week. But a variable can store multiple values of the same type. Again, notice they all have to be the same type. So as I define these, I've got all my strings, all my integers, all my floats. I couldn't, for example, put a word in here. So with these specific things, it must be the same type. So you can see here it says I'm ints. This isn't okay. You're putting a string in a list. So I have to have one type. Now there is a way to get around that with my making arrays that have multiple types, which you will learn in chapter 7, I believe, if you read into chapter 7. I think it's also at the end of chapter 8, but there is a way to use different types in one array, but that's more advanced in our class, so don't worry about that. Just know for now, a variable can only store, or an array can only store one value of type. The values are stored in consecutive memory locations, and it is declared using a bracket operator. So you can see right here, int tests with brackets after it. That is my thing that now defines this as an array. Now, here's another use for defines or constants, because you see here I put 12 a bunch of times, where 12 is like the max number of months. So that's what you're going to see in these slides where they say I size and I size equals 5. It would be good practice for me here to say const int num months and set that equal to 12. That way, if for some reason the calendar changes and we get rid of August, then I could just go in here and change that to 12, which instantly changes all of them. Or if I found I had an off by 1 error or something and I actually needed to be 13 for whatever reason, then I can change it in one specific location. So again, this is another case, another entity where you want to minimize the number of numbers that you use. You always kind of want to put a name on these sizes so that you know why it is that size. That's very good practice. But yeah, so that's how you declare them. Here there's a full declaration, where again, what I'm doing when I make that declaration is I'm setting different element blocks out. So this definition, int tests I size, the I size is 5, allocates 5 memory blocks, where again, the 0th element refers to the first cell. Now, a big error that a lot of you are going to come across is referring to things that are outside of range. So you're going to see an error at some point in your careers that says int out of range or value out of range or whatever it is in every other language, which basically means if I wrote, for example, tests of 1, if I wrote that, then I'm referring to this memory block right here. The second element in the list is labeled test1. But if I did some kind of loop and somehow, for example, I got to tests of 6, or rather but yeah, I'll put test of 6. Then I'm looking for 0, 1, 2, 3, 4, 5, 6. So I'm trying to refer to this memory over here, which is a problem because I haven't allocated that memory to tests. Now, different languages and different programs will say either, okay, that's fine, cool, or it'll stop you and say error int out of range. So most likely you're going to see an error int out of range, but this is actually a common method of attack. Because if, for example, I knew that your password was stored over here in memory by using some background manipulation, then I could use an overloaded array at some point, go past the end of the array to access that file location, and then push that out into loading into a password or something, which is a common technique for infiltration attacks. So just be warned that some languages will stop you from accessing that memory, and some languages will just be like, it's fine, sure. Just shove whatever you want into this little tiny cell. So often it's good to put limits on what you can put into these things and so on. But I'll leave that for your cybersecurity course when you get that. So anyway, when you define these things, the size puts the number of arrays. If I made this size 6, then it would have made another block, and so on. So make sure you only reference things in the specific blocks. So this is the definition. The data type, or int, is the type of all the elements in the array. Tests is the name of the array. And then this thing is known as the size declarator, which again, you don't want to put numbers in there if you can avoid it. You always want to put in some type of constant or define to say exactly how big that thing should be. Again, it's very bad practice to just put a number in there because you don't know why it's declared at that size. Like if I declare the number of, or the rainfall months to be 20, then I'd want to say something like the max number of months I have, or why I did that specifically. But then also note that the size of an array overall combines not only how many slots are there, but how many memory is allocated to each slot. Because remember, some data types just take 1 byte, some of them take 4 bytes, some of them take 8 bytes. So when I make this size declaration, when I declare this thing, whatever this type is, it makes 1 block for every one of those types. So if I declare something as an int, it takes up 4 blocks, that means I've got 4 bytes in each cell. And then in this case, I've defined 5 of those, so I've got 20 bytes of memory total. And that is the size of an array, which you can usually access. I don't know if there's a specific thing, but in this example here, let's see, month names dot size. Yeah, so that's what you do if you use this method right here, month name dot size. That'll give you the total memory allocation for that array that you have. Oh, neat. Interesting. Why did it do that to me? Oh, cool. That's cool that it autocorrects you now. So yeah, that's what size is. Size is the total size of all the stuff in there, which you then can use that to kind of find the number of elements, because if you know the number of bytes per element, and you find the total size of an array, then you can divide the size of the array by the number of bytes to get the number of elements. Just like a little bit of mathematics. Because again, this is equal to size. So you do a quick inversion. And it's kind of the only way to find the number of elements in an array in C++, which you will have to do at some point, but you probably won't for our class, so I'll keep going. So here's some more examples. So we have int tests iSize is a 5-element array of integers. Double volumes is a 10-element array of doubles. And right now we're just working with one-dimensional arrays, but you can also declare multi-dimensional arrays. And that's what we'll talk about when we get back from the break. Okay, so that's what arrays are. That's how we define them. We'll do some examples in a second. But now let's talk about accessing those elements. Because again, what I've got here, what I did in all of these cases, is for each one of these arrays, I can access any one of these elements in the list, where you can imagine each of these just like a big block of memory, by just putting the name of the thing, like month, numbers, and then a specific value in that. And again, the number that goes in here, when you're referencing them, counts up from 0. So in this case, I'm referencing the 9th entity. So month numbers here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the thing stored in the 8 location of month numbers is the value 9 in the specific case. And again, that's because we start counting at 0. So another example, month numbers of 0, that value stored in it is 1. And this is a big lead to off by 1 errors, because often you're going to want to start counting at 1, but remember, you always count at 0. And that means whatever element you're putting in, you're always locating the element in the end plus 1 slot. So if I put an 8 here, I'm actually referencing the 9th slot. Okay. And I think you really have to just do that and make that error to really learn what I'm saying. So don't worry if it doesn't make perfect sense. But yeah, each array element has a subscript, which is used to access the elements. Subscripts start at 0. This also might look familiar because strings are arrays. Remember before when we were talking about words and things and we stored them in boxes, like the word hi was H, I, and then the null terminator? It's because strings are essentially an array that has enough cells to hold whatever string size that you put into it. It's kind of like a dynamic array set. And C strings are strings that are defined as their specific array sizes and stuff like that. So this is something we've seen before a long time ago. But anyway, you refer to each location using the subscript. And remember, subscripts start counting at 0, not at 1. So array elements are accessed by the name and subscript, and they can be used as regular variables. So you can see here, tests of 0 equals 79. This assigns 79 to the 0th slot. So what I'm doing is I'm shoving a 79 in here. So when I do cout of tests of 0, I'm printing 79. And then here's an example of taking an input and putting into test 1. So if I typed in like 11, then I'd be putting 11 directly into that cell. So you can use cin and cout just like normal. You can use regular arithmetic, where essentially using the subscript, you're referring to a specific location. So putting this here, this is the same as writing 79 plus tests of 1, which is 11, and then assigning that to tests of 4, which is 90. Sorry, I don't know why that was so hard. And that's what I'm assigning into 4. But do note that you can only refer to one thing at a time. So if you did cout tests without the braces, you can use a full array like this. Again, back to my example here. I could use month numbers as an array in some contexts, where I can use it to pass to functions. I can pass a full array into a function and do other things with full functions. But you cannot print a full array of things. So cout tests won't work. So if I wanted to, for example, print out every available month, I'd have to use a for loop. Or I could do a simple for loop that just says for int I equals 0, I less than num months, I plus plus. And then I do something like cout month numbers of I. And then what this would do is say, okay, I is equal to 0, print the first thing, which prints January. I is equal to 1, put a 1 in there, print February, and March, then April, and so on, until it reaches the end, as I've said here, by the number of months. But do notice in the way that I've written this, I'm printing out the 0th, the first slot, to less than the final slot. So I'm printing out 0 through 11, since there are 12 total slots. So just be a little bit careful on that, because this is the main case where your off by 1 errors are going to come from. Because if I would put this less than or equal to, then I would get to the last one, I'd put 12, and I'd try to reference month numbers of 12, which doesn't exist, and I'd get an error for that, and it wouldn't work. So these two things, what you're setting equal to, and your equivalents, or just straight strict or non-strict inequalities, that's what's going to cause your off by 1 errors. Jen, you'll see when you actually work through the lab. So that's it. That's how you get them out, using subscripts. And then inputting and displaying array contents. cout and cin can be used to display them. I just showed this to you. So I'm going to skip ahead a little bit. I'll just keep going. I said this again, you can refer to those by either using integer or variables or expressions. So when you're accessing the thing in there, you could also put in a calculation of different sorts, which you'll see is useful coming soon. I just showed you this thing here. Again, just using a little for loop to access every element. Again, notice the strict inequality here. We're not using the equals sign because that would put me off by 1. But this is another thing. You can't directly copy arrays. Like say I wanted to make another array that was month names, or like string month names duplicate. I don't know, something like that. And I also called it the number of months. I couldn't just set month names. Oops. Tried to hit tab, but I missed. Duplicate equals month names. Like, this is not a valid thing. I can't just set an array equal to an array. What you need to do instead is use this same tool where I need to put them in one slot at a time. So I'd set, once again, I'd set an array, go through them one at a time, and then I'd say month names duplicate of I is equal to month names of I. So if you're copying an array into another array, you have to do it one at a time. Now, there's also a function you can call for this that's built into it, but I mean, I think it's harder to remember the name of that function than it is to just write the loop that that function calls and does. But there's just a big overloaded function that says, look at what the types are, make sure they match, copy them in, and so on. And you can see here, this is not a modifiable value when you're using the entire array. So this is not valid. But this can work to copy the whole thing over. Okay, that's the same thing here. You got to access them one at a time. You can use data files, but I'm going to skip over data files because we're not going to use that. Do note that in C++, if an array subscript there is no check that the array subscript's in range by default. So an invalid subscript can cause the program to overwrite other memory or crash, depending on your IDE if you're debugging. So if you just ran it, for example, I could put an array of size 3, and then I could reference the 4th slot and put num of 4 equals 25, which essentially just shoves it at the end, 2 slots away. And you have no idea what's in that other memory over there. Again, this could be the cell for your login information or something in your specific memory block. So be warned, there's no implicit check there, so you have to do other things to check properly. Okay, and this kind of goes into that thing. And here's off by 1 errors that I talked about. These most often occur when a program accesses data one position beyond the end of array or misses the first or last element of array, which just comes down to you naming things as 1 instead of 0. So don't forget, we start from 0. Always remember to count starting from 0 in C++. Again, you'll see this, and hopefully you remember this part, and you're like, oh, off by 1 error, that means I need to change my equivalence. Again, off by 1 error I would get if I put less than or equals here. Because that would mean you can just trace this through thing by thing. You could throw a debug set right here and just watch it going step by step. Let's see, did I do anything that I don't even know if this is going to compile? No. Oh yeah. There we go. Let's compile. That's all I want to compile. Okay, so this is the program we did before. Let's just get there. April to June. Okay, so I'm just using this as a dummy, but you see in this case right now, I have non-month name duplicate. See, it's completely empty. So if I pull this out right here, I've got it completely empty, so I can just pin it. And then I can move it up here. Make this full screen. You can see each of those slots. And then in this one right now, I have i's set equal to 0. That's my current value of I is equal to 0. So I can pin that as well, so we can watch I going down. And then I have my month names, which has some slots available. Now notice that in my definition, anything I didn't declare officially, because I stopped at August, right? Anything I didn't initialize is set to null. So it's the null empty string for each of 8 through 11 there. But that's still fine when I try to do this copy. You can see that that's the general copy there. So you'd see we can also pin this one and just watch it. And essentially what you see is it's going to assign this to this in this line and then go to the next loop. So you see continue. Oh yeah, there you go. See, it put it in there. So you see after the first loop, it put January equals January and February equals February. Again, right now I equals 2, so I'm referencing the second slot of it as I go through it. And then we're going to keep going. Let's go to the very end. Copy, 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 copy. And it can copy nulls over. And now we're at I equals 11, so I'm at the location of the last slot. And now I'm going to reference the 12th slot. You can see right there. I'm already going to fail. And I get an exception thrown. Access violation reading location. Which essentially means on my hard drive here, my system said, you can't access that memory beyond where your cell is. But that's a protection from my system, not a protection from C++ itself. So C++ will not check for you. And I can even tell it not to even break or care. But yeah, so here's the error you'll get for a off by 1 error. Because again, the idea is my last slot is slot 11. And I've tried to reference slot 12. Is there any special include we need for arrays like with strings? Nope. Arrays are built into C++. I will say that arrays are kind of a special type for C++, because if you get used to other languages like Python doesn't have arrays, it has lists. So when you take your math course, or in your math course already, you've probably learned about all the different data types. And then you can see it tells me right there. Index 12 is out of range for 0 to 11. It even warned me because it noticed that. And great power of these IDEs. C6201. But yeah, no special include needed. There might be one for a tool we'll use later, but arrays in general are in default for C++. So much stuff open. Wait, where's my... There it is. All right, so that's the off by 1 error. Just be warned, it's going to happen to you at some point in your life. Yeah, so here's some examples. I think what I want to do... I want to make this the participation for the week to define all of these things, because that'll be a good test. But we still got to talk a little bit further before we can do these two, so I'm going to come back to this one. So here's another example. Which one of these is a size declarator? When I have int score 15, int score of 6 equals 5. The size declarator is the 15. That's the one that says how many, or how big the size of the thing is. As says I'm going to have 15 elements. So score of 6 means I'm accessing the 7th element, and that 6 is the subscript. All right. And I'll let you think about this example here. But I'm going to keep going because I got to get to section 7 here. So array initialization. Again, this is something else I already showed you. An array can be initialized using execution using statements. So you see tests of 0, tests of 1. I can assign the values one at a time. You can even iterate over an array and assign them all. Or you can array or initialize it with a list. And that's what we have here. Use curly braces for that. That's what I did in all these examples. Oops. Here we go. That's what I did in all these examples here when I defined these. These are initialization lists. But again, I don't necessarily need it. I could just put month names, or string month names, num, where is it? There it is. Num months. And that could be my initialization of the specific set. And then I could just put month names equals this list afterwards. So it's kind of the same thing as before, where you can initialize it and then assign it based on time. It's just usually easier to initialize all the ways. But yeah, again, you'd have to do this one at one time using a loop and go through it and set it manually. So if you wanted to do it specifically, I'd say just use this specific setup, just so you can modify it at defined time. All right, so you can initialize them with these strings. And it does not have to have the same number of elements. So if I had left off 84 here, it would just leave that blank, which is a nice control of C++. When you put the size in, it initializes all the cells. There are other languages where you'd have to do a loop and actually implement every single size and force them to start and set to 0 before you can use them, like Python and Fortran do that. But luckily in C++, it sets them all up for you. Now there's another tool called a vector that has a little bit more use if you have a lot of values you need to put in an array. Like if you need an array of 1,000,000 zeros, vectors are a little more useful for that. But we'll talk about that in a couple weeks. Always start at 0. This is something your textbook likes to talk about, so it's in here, but I think this is particularly bad practice to start by numbering off 1. There are some uses for it if you want to use the 0th cell as an identifier. That's common, but that's a little more advanced usage. Again, if you don't initialize it, so you can see I can initialize a size 5 list with just 2 values. If it's not initialized, it'll just be 0. That's all there is to it. Same thing with strings. If you put in a string set, if it's not initialized, it'll put it as just a space essentially, and that's what I showed you before for those cells. You can also get the size of the list, so you don't necessarily have to determine the size if you have a full array list there. Just note that it's going to put the number of values. So in other words, I don't even need to have this here for the number of months if I only had 12 things. Again, this kind of is bad practice as well, because then I don't know exactly how big this thing's going to be, especially as I work through it. I have to go manually count these elements. So it is better to just define it yourself. But C++ can do that little bit of efficiency for you. Where, like, if I hadn't put this here, it would define it as a 3-element array. Okay. Do note that in C++ 2011 higher, you can initialize elements in a slightly different way, where you can just put the thing in parentheses rather than the equal sign. So see int length in parentheses, the same as int length equals 12, but it's essentially the same number of characters, it's just slightly different format. So you can do that if you want. But you can do this to do some error checking and data type checking. This is kind of a weird place for it, but you can use that if you want. I'm just going to keep going. It's just in there from your textbook, so I threw it in for use. The range-based for loop. I'm going to completely skip over this section. This is, again, from your textbook. If you want to read about it, you are welcome to use it. But this is similar to how you do for loops in Python. So you can learn about that if you'd like. Otherwise, I'm going to skip ahead to 8.6. Give me a second to find that slide 34. Oops. Yeah. Essentially just a different definition of a for loop that just says iterate over these things as long as there are things, and it can help save you from off by 1 errors. So you are welcome to use the range-based for loop, but I'm going to leave it off of this class. Okay, so you can use variables like normal. You can use increment and decrement operators. Just make sure you know what you want to increment. So this example here adds 1 to whatever the values is. So I can give you an example of this here. Like for example, if I did rainfall amount of I++, and let's say I was equal to 1. Then in this specific example, I'm putting rainfall amount of I++, which is 1, which says rainfall amount of 2. So if I wanted to add 2 to a specific value, I could say plus equals 2 or something like that. And what this would specifically do is go to the rainfall amount, put in a 1 there, iterate it to 2, which grabs the 2.65 and then changes that value to a 4.65 by using this plus equals. Now, alternatively, I could do rainfall amount of I and then plus plus on the outside, where what this does is this is using the plus plus operator on the entire thing here. Which is the same as doing like plus equals 2, but you see rainfall amount plus plus will find the ith entity, which is 3.41, and increment it by 1. So just be careful. Generally, you want to increment over your entities inside. And don't forget, you can also use, prefix incrementers and decrementers to get the thing before you get the entity out. Or after it, depending on where you put it. All right, so just be warned, these are different. So this is another mistake that's common to make, is putting the increment afterwards. Where this adds 1 to the value, this increments the integer inside to get you the next value. Okay, you cannot copy with assignment statement. This is what I showed you earlier, where to do the full duplicate copy, you have to do a duplicate 1 at a time. You also can't compare arrays, so you can't use equivalence tests to see if they're equal. You have to compare them 1 at a time, so you got to search through them. Where essentially you could do another search type loop, like an if loop, like a while loop is what they did here, where you just go through the entire set of arrays and check for each one, is this one equal to the other one? So essentially I'd make a for loop like this that says if this thing is not equal to this thing, then I break, or I leave, or quit, or something, I don't know. Whatever we want to do, where this would check 1 at a time and say, okay, is the ith thing of this one equal to the ith thing of this one? Or I could use that for like integrity checking to see if I copied properly, or things like that. So there's some examples of that. You can find the sum of them using accumulators. This is a very useful tool that you might use this week. Finding the largest array element. This is actually a big study point in 335 when you get to algorithms, because finding the largest and smallest elements of arrays is a little bit of test of efficiency. So you'll see this come back a little bit. But here's a simple example of finding something where, again, I have an array called tests. I iterate over tnum, and I go through one at a time, and I check, okay, is this element I just found larger than the largest value I've found so far? If it is, then that's the largest one. If it's not, then don't add it, and so on. So here's an example to find the largest. You could do the similar for smallest just by flipping a sign and changing some words, of course. But yeah, this is a simple search algorithm for largest and smallest entities. And then there's sort algorithms and all these different tools that you're going to learn about later. Okay. Now, there are good times and bad times to use arrays, and if you only have a few things, I think it's really from practice. Like, you're going to see many times if you look back at your old code, just think, would this have been better to call something rain value 1 and rain value 2 with words, or would it have been better to put in one simple array? Or like another example, like the triangles thing we did last week. It would have been better to have that as a 2-element array rather than using a global variable to get around using the second value. So in general, if the input data in an array must, or in a variable must be processed more than once, an array is probably a good idea. But if the input data is only processed once, an array is probably not needed. All right, so there's other tools as well to get used to it, and once you start using arrays and start putting them in your code, I'd recommend just like go back, look at the code we've done so far this semester, and just think, how could I have used arrays here? Because there are many cases when you had to do something very annoying and inefficient that an array would have made much simpler. Okay. Array elements, C strings. Again, C strings are a specific version of an array where you have each element stored in a specific cell, and each cell is a character. So when I declare a string, I'm actually declaring an array. So when I make an array of strings, like I did here, I'm actually making an array of arrays. This is effectively a 2-dimensional array. But you'll see more about that later. Just know that essentially what this is here, you see when I'm looking at January, notice it says constant character 8. This is actually a 1, 2, 3, 4, 5, 6, 7, and then null terminator string array. So January is an array of characters, and that's what strings are. That's why we have to include strings, because essentially putting in strings allows us to use them just like normal variables and characters, even though it is an array. So just know you've been doing arrays this whole time, because every string you've ever used is actually an array of different pieces. So you can actually get the individual elements of a word one at a time, individual letters of them, by referencing them with their index. So for example, do I have anywhere where I stored a value? I'll just use an example like string April equals April. I could get the R out, for example, if I just took April of 1, 2, 0, 1, 2, 2. And that would be my R. And so on. There's many good uses for this. Remember when we did that one thing that was like the toUpper function? You could make a loop over a string, and you could use that to capitalize every letter in a set just by doing something like for I equals 0, blah, blah, blah. Take the argument of April of I and set it upper. And you could use that to completely lowercase or completely uppercase a word, and then completely bypass the need to check for uppers and lowercases by just forcing everything to uppercases or lowercases, and so on. Many good examples of use that you'll see coming up for that. Okay. And then finally, parallel arrays. This is the very last section I wanted to cover today, so that's why I was going a little fast. I want to make sure we got here. Because this is going to be very useful for this week, where this is, again, the concept I did here, where if I define arrays alongside each other, essentially, then I can make an array so that each index is associated with the same things. So in this case, I have January, which is the first month, which had a rainfall amount of 3.03. So in general, let's return this to before, the index I equals 0, if I used 0 for each of these, refers to info about January, where, again, month names of 0 oops, month names of 0, month numbers of 0, and rainfall amount of 0 all refer to January, because each of these are things about January. Even though implicitly, if I just looked at this, I'd say, okay, 3.03 itself doesn't really have anything to do with January, but if I line them up in this sense, then I can use one specific array to refer to all of them. So for example, if I said something like, which month do you want? And I took an input from my user and stored it as month number or something like that, like say, name a month from 1 to 12 that you want. They input month 1. Then I can hunt in here to find 1, which gives me an index 0. And then I could get all the information about that first slot, including the rainfall amount and so on, and many, many more examples. So to give you another example of that, parallel arrays are 2 or more arrays that contain related data where the data is related by the subscripts. They do not have to hold data of the same type, and this is a way of associating them together, or use the subscript to associate the data together. So here's another example, where, for example, maybe I have a bunch of different students, like I have Alex, and this is like for the exam of a different piece, and maybe the average was, or his average was 67, and his grade, or the average on this test was 67 or something, and then the individual person's grade was, I don't know, 80. And you see if I use the 0 reference slot, then everything I find is related to Alex. I could even have like assignments, assign, input this was like exam 1, or something like that, where I can just use this data table that I've essentially built to put everything together. So here's another example again, where make the size 5, declare them all the same size, and then you can associate everything together and keep adding things like that. So this is an artificial way of making a table, in a sense, where each one of these different arrays would refer to a different column in the table. And I can reference every row, or each individual row of the column, by saying a different subscript when I reference them. So those are linked arrays. Again, they're going to be very useful this week, which this is essentially how you need to use it, where you're going to want to find, for example, you'll say they want January to April. So then you associate January with the 0th array entries, and then you go 0, 1, 2, 3, and that's April, and then you have that as the end of the month entries. And I'll show you the specific example or specific solution to this when we come back from the break, but that should give you a pretty good starting point on how to do the linked arrays this week. Again, I expect this to be another pretty hard lab. But here's another example of how you could use the different things. Like I just find the student entry is I equals what, and then I can put the name, average, and grade for that specific person. Lots of examples here. And yeah, I think that's the end. And then type define and everything else we'll talk about when we get back. So that's it for today. Good, we got a lot of time. So let me go back to that participation and get it up so that you can submit that. So did anyone have any questions on anything I talked about before I let you go for today? And the participation was that one, this one, where I want you to answer all these. So give me 1 second to get that up. But if anyone had any questions while I'm setting that up, just let me know. Assignments. What is this? Unit 11? 12. 12. 11? 12. All right. Unit 12 participation. And this will be our last participation for the semester as well. So don't forget about it. Settings. This is going to be due this weekend, which is the 21st? Question mark. Save. And answer all these pieces, but like A and then your answer B, C, D, E, F. This isn't a multiple choice question. This is just answer all of them. And there we go. You can see it on Gradescope right now. It'll take me a second to get it onto Canvas as well, but I'll publish at the Canvas. But if you want to jump straight to Gradescope, you can find that and answer it as Unit 12 participation. But that is it. That's everything I wanted to cover today. just lab questions, but those are for Friday. Again, there are no Zoom lectures this week for Wednesday or Friday, but if you have questions, you can ask me in Discord. Yes. I talked about the labs at the beginning of classes a little bit as well. I think you were there. Yeah. All right. Yeah, and don't forget, I am available for the full time in Discord, so I am not available on weekends. So a lot of you keep asking me questions on like Friday night or Saturday morning. Sorry, I cannot answer you, but yeah, don't forget you can ask me questions. And your IAs, don't forget your instructional assistants are also available for the full durations of Wednesday and Friday. No, you're answering all of them. I was just saying we didn't know how to answer ENF yet. But all of them. I said ENF because this part was before like how to initialize them. But that's why I covered that. So now we can answer all of them. So yes, answer all of them. Yeah. Thank you for asking that. I forgot to delete that little thing there. All right, so thanks everyone for coming. Again, it'll be one more second until I get that onto Canvas as an assignment, but I'll do that right now. So you should see it show up in 4 minutes. But otherwise, have a good day, everybody. And have a good break, since I'm not going to see you on Wednesday, Friday. Don't forget I'm available in Discord. And see you on the 29th for our next lecture. Thanks, everybody. Have a good day.